Myself, Lohit, student of BE Mechanical Engineering from Dr. Mahadevan College of Engineering and Technology. Today, I'm going to present my project for the Altair romAI contest titled Development of Reduced Order Model for Hybrid Thermoelectric Energy Harvesting System using a mud stove and thermosiphon cooling simulation in Altair Twin Activate. Problem statement. As per 2025 data from Times of India, around 2.4% of Indian households are still unelectrified, where this project was done in my NPTEL summer internship at IIT Kanpur, so that it is focused on Uttar Pradesh, where it was a real-time problem where I have taken from the rural areas. Nearly 17% of households, that is about 14.6 million homes, do not have electricity connections. In rural area, people depend on much stuff, but most of the heat is wasted. At the same time, their basic energy needs like lighting and mobile charging are not fulfilled. Conventional generators are very costly and fuel dependent and require frequent maintenance. Finding the optimum parameter for the energy harvesting is also a time consuming and expensive thing in our project since it's needed repeated trials. Moreover, combining CFD, thermal, and electrical simulation is a technical complex and slow down our innovation. The solution to overcome these issues, I designed a compact and eco-friendly hybrid thermoelectric energy harvesting systems. This system uses a Peltier module to convert waste heat from the mud stove into the DC electricity. But it uses a thermosiphon cooling for maintaining the cold side temperature effectively, so that it satisfies feedback effect and it able to produce the DC electricity. The project goal. The main aim of the work is to create an AI-based reduced order model for the system. The romAI replaces costly CFD and multi-physics simulation with fast real-time predictive model. The model is trained with experimental data. Accuracy is checked by comparing the predictions with laboratory results. Finally, the digital twin is deployed in Altair Twin Activate for fast analysis and system optimization. Training dataset. In the lab, I carried out 10 trials on the prototype. Inputs include ambient temperature, hot side and cold side temperature, water inlet and outlet, rod diameter, peltier counts, and pipe diameter. Output recorded were open circuit voltage, power, and efficiency. Along with this, I generated a synthetic dataset to expand the range of conditions. This helped the romAI model to learn better and give more reliable prediction. The training loss came down to the just 0.0048, which shows very good accuracy. Self-considered data set in model settings where I used nonlinear model and auto exploration features are used. And for iteration, I have used 200 approach for training parameters. The final training loss achieved by the romAI model is very less, and it was excellent conversion and minimum error between the prediction and actual value. The optimized model provides a confidence in using the digital twin for the real-time simulation and system optimization. And I created the 1D simulation twin activate where it represents the experimental data were input to the romAI model, where it was trained by the experimental datasets, where I have collected the data from the trial of the prototype from the lab. The results were produced very accurately. Output of the model. The R square value of the predicted efficiency output is nearly over then 0.996% for all outputs like power, voltage, and efficiency percentage. This extreme high output demonstrates the model's strong predictive accuracy and excellent agreements between the predicted and actual system performance. In conclusion, I successfully developed a reduced order AI model for hybrid thermoelectric energy harvesting system. The romAI model achieved an accuracy of more than 99.6%, which was validated against the experimental results. Most importantly, the digital twin reduced simulation time from hours to less than 1 second, enabling a real-time prediction and optimization. This makes the system practical for designing low-cost, sustainable energy solutions that can directly support the project for fast prototyping. For this work, I refer to the Altair's romAI data and Twin Activate documentation for model building and deployment, and science direct publication on thermoelectric energy harvesting to understand the principles and application, and Government of India Rural Electrification Statistics to identify the real world needs, and US Department of Energy guides on waste heat recovery technology for background energy efficiency. And this is my presentation. Thank you.